Hi everyone, welcome back to our machine learning sessions. Today I'm going to discuss one of the very important topic, that is what is the difference between overfitting and underfitting. In interviews you can expect this question: what is overfitting, underfitting? Explain with an example. You need to get clarity what is exactly overfitting, what is underfitting. You need to explain with some simple example. Let us go in depth what is overfitting, underfitting. Let us see. So before explaining these concepts, so I will take some simple example. So let us take these. So overfitting occurs when the model learns the training data too well or capturing the specific details that are not representative of the underlying patterns in the data. So what exactly it is? So for example, let us take simple example. Simple example. I am training my student for data science. I explained him various topics like Python, machine learning, and so on. So I trained my student very well. And what happens is he is attending data science interview. During training, let us say what happened is during training, whatever the topics I covered in the data science, I asked some direct questions. Something like, what is Python? What are the programming features of Python? What is supervised learning? What is supervised learning? Let us assume my student by hearted all those questions. So what is supervised learning? He is well known. So supervised learning is nothing but classification, regression, all those inputs, and means he is well known about the question and answer. If I'm able to ask the question, what is supervised learning, he can able to answer all those questions because he by hearted the questions. Let us assume during interview, they ask some question like this. So your diabetes data set having these many features, 8 features like BMI, body mass index, and blood pressure, glucose, and so on. And finally, outcome is whether the patient is diabetes or not. Let us assume this kind of question they asked. Yes or no. So then they will ask some innovative question like, you have given this diabetes data set. On top of this diabetes data set, what kind of machine learning algorithm you are going to apply? What are the what category you are going to apply? So since my student is overlearned with only specific, means he by hearted some questions, or he know if we ask in the same way only he is able to answer. What it will happen is he may fail in this interview. So during training, because I asked the same questions, whatever I thought, so he may accurately answer. Let us assume 95% of the answer he is able to answer. But during testing, since the questions are asked in a different way, maybe he failed to answer 50% or 60%. So this kind of concept is called as uh, overfitting. So what is overfitting means? During training, it is performing well. That's what if you see the definition. This overfitting occurs a model when it learns the training data too well. Means whatever the training data I'm giving, my student is able to understand Python, machine learning, and if I ask the same questions, he is able to answer. But it is not able to capture the exact patterns, and with unseen data, it may not perform well. So with unseen data, it may not perform well. The model performs well on the training data, but poorly on the new unseen data because the questions are asked in a different way. It is not able to answer. And this may be excessively because of complex structures, capturing noise and outliers. For example, I'm training some salary prediction. So most of these salaries are something, some freshers are 1 year experience, they are having salary 20K, 25K. Around, let us assume most of the records are having 40K, 20 to 40K. Very some few 10 or 20, 30 records are having 1 lakh or 2 lakhs salary, 2 lakhs salary or 3 lakhs salary. Let us assume very few records are having these many salaries. So these are called as the outliers because very few records, there is a huge difference between 20,000 to 2 lakhs. Very huge difference between the salary of a fresher and some 10 years, 20 years of experienced people. So if I don't do normalize here, normalize. So what is normalize? What are the different types of normalizations that you can go through my separate sessions on normalization techniques. Just I'm giving an example. So these kind of outliers present. So then my model may not understand some of the records may predicted wrongly. So my accuracy of my model is maybe vary during testing because it learned those patterns, but during testing, it may not able to predict because very few outliers present in your data set. Similarly, for example, if you take your data set, diabetes data set, if you see sometimes it is giving blood pressure is 0 and skin thickness is 0 in your data set, somewhere in body mass index is 0. So if you see these kind of records are called as outlets because a live human being without glucose or blood pressure or body mass index, that is nothing but dead person, or the doctor may forget to find enter these values. So these are present for that patient, but doctor forgot to enter during the entering into the database. So these kind of data sets, first we need to handle those outliers. Without outliers, so your model may predict unseen with unseen data, the model performance will vary. So for example, in training, it is performing 90%, in testing, it may give some 60% or 40%, something kind of thing. So that is called as overfitting. So what is overfitting means the model performs well during training, but poorly on the new unseen data. So due to some noise or outliers, it may happen. So how to handle this overfitting? We'll take a separate session. We'll discuss how to handle this overfitting within the given data set. Next, what is underfitting? What is underfitting? So let us see our slide, what it contains. So what is underfitting? So underfitting occurs when a model is too simple to capture the underlying patterns in the training data, resulting in the poor performance on both training and unseen data. The model performs poorly on both the training and test data set, then it is called as underfitting. So for example, the student who is not interested in some engineering or let us say doctor course MBBS, but parents they forcibly joined them to either engineering or MBBS. Let us see, the student is not at all interested in engineering, but due to the force of the parents, they joined in the engineering. So with no interest, he is not studying or he is not learning all those concepts during training. Also, let us assume he got some 40% of the marks during testing. Also, he got exactly 40% or 45% of the marks. Let us say some 35% or 40% of the marks. So during training or during testing, in both places, it is not performing well. That is called as underfitting. So what is underfitting means? The model is poorly performs on both training data and unseen data. This is called as underfitting. Let us assume your data is too clumsy. You wanted to predict diabetes prediction, By mistake, something happened in your data set. Some of the records out of 1,000 records, let us say some 100 records are diabetes records. Some 100 records are some heart disease records, and some 100 records are cancer disease records. Means your data set is completely clumsy or irrelevant features or irrelevant data, but you are trying to predict diabetes prediction. What it will happen is, as a human being, I trained with data science questions, but if they ask big data questions, or I trained with Python, they asked R language questions. I trained with some SQL queries, but they are some other language. So what it will happen is, definitely with no interest or no capture the required patterns, definitely I will fail in the interview. So same thing. So if I don't give the proper data to my model, it will not perform well during training or testing. So it is not able to understand the what are the patterns in your data set. It will perform very low during your training or testing. So that is called as underfitting. So underfitting. So what is best fit? Just maybe I will give the definition, but actual best fit we can find during implementation only. What is best fit means, during training also it is performed 95%. During testing also, let us assume 94% or 93%. 93% or 94%, that is well and good only, because during internal test the student got 95%, and during external test he got some 92 or 93, that is also very good percentage. So what is best fit means, during training and testing if it performs well, that kind of models are called as best fitted models. So best fitted models. So underfitting, so the model performs poorly on both training and testing, then that kind of model is called as underfitting. So just to see an example, what is underfit is, if the student is not at all interested in learning, which will result both class test or external test will result in low accuracy. And overfitting means, during training, the due to the interest or due to the student by hearted the questions, he may get 98%. And during testing, if he get some different questions which he didn't by hearted, then it will result in low accuracy. This is called as overfit. What is best fit means, during training and testing also, which will gives better accuracy. The student, instead of by hearting or instead of without interest, he will learn conceptual. For example, if I ask some supervised learning question, he will learn in depth with all the definitions, example calculations, and with innovative thinking. So if I give this diabetes data set, this is called as classification. If I give heart disease data set, or if I give salary prediction, so this is called as regression problem. So he will discuss, means he will learn with some critical thinking or innovation way of reading. So then he can able to answer, he can able to perform better in both internal test or external test. So that kind of model is called as best fit model. We also need to design best fit models instead of underfit or overfit. How to overcome underfit or overfit with example implementation, we will see in the next sessions. So see here another pictorial representation of underfitting. If you see, most of the points are classified in some class, and only some 2 points are classified in class B. Let us say this is class A and class B. So if you see, if I fit some line, only few points I fit in some class A and other points in class B. And if you see, what is overfitting is, I'm drawing this line through the points. Each point I'm covering where it will overlearn nothing but by hearting, and where during testing it may fail. So what is best of it means, we need to cover, but we need to understand all those patterns. So that is called as best of it. Thank you all. So I hope you understand what is underfitting, what is overfitting, what is best of it, and what are the ways to overcome this overfitting, underfitting. We'll see in the next sessions.